Imagine hovering at 30,000 feet, separated from the freezing atmosphere by only a thin aluminum shell, while the world moves beneath your very feet today. But the thing that truly keeps this 100-ton metal beast from falling is the heart of fire burning fiercely inside those magnificent silver wings of power. Welcome to the sanctuary of aerospace engineering, where every single micrometer of deviation marks the thin line between absolute safety and a catastrophic mechanical failure. Look closely at this tiny blade. It must endure tens of tons of centrifugal force while rotating at speeds that would shatter any ordinary piece of metal. To understand the scale, look at this 3-meter tall engine. It is a masterpiece of complexity, containing more technology than a modern high-performance Formula One car. Every component is measured against the laws of physics, ensuring that the power generated can withstand the most brutal conditions found in our upper atmosphere. The air is compressed, ignited, and expelled with such force that it pushes the entire aircraft forward, conquering gravity through sheer mechanical will and brilliance. We are about to enter the heart of the machine, where metallurgy and precision engineering meet to create the most reliable power source on the planet. Our journey begins in the heat of the foundry. Here, nickel-based superalloys are melted in a vacuum to ensure there are no impurities in the metal. So imagine baking a cake where a deviation of 1/1000 of a degree causes it to shatter instantly. This is the reality of aerospace-grade casting. These alloys are the superheroes of the material world, designed to maintain their strength even when the temperature rises far above their own melting point. We aren't just casting metal, we are growing single crystals. This unique structure allows the turbine blades to resist the creeping deformation caused by extreme heat. By eliminating the boundaries between crystals, we create a material that is virtually indestructible under the intense thermal stress of a working jet engine core. The cooling process is painstakingly slow and precisely controlled. It is during these hours that the metal gains its legendary durability and heat resistance properties. At 1600 degrees Celsius, most metals would turn into a puddle. But our nickel superalloys stand firm, defying the very limits of classical thermodynamics. This is the raw muscle of the civilization. Each blade is born from a process that aligns every single atom to serve one purpose: unstoppable power. The rough edges are removed, but the journey to perfection has just begun. Every surface must be refined until it meets the exacting standards of flight. Thousands of these blades will work in perfect harmony, catching the wind and converting fire into the thrust that connects continents across the vast blue oceans. Logistics in this factory are as precise as the parts themselves. Every component is tracked, ensuring that no errors occur during the transition to machining. Under ultraviolet light, the tiniest imperfections are revealed. If a single crack the size of a hair is found, the part is immediately discarded forever. Laser scanners map the geometry in 3 dimensions, comparing the physical part to the digital twin with a precision that exceeds the human eye's capability. This is where magic meets reality. We are sculpting the future of transportation, one atom at a time, within the walls of this high-tech metal cathedral. As the foundry work concludes, the metal is ready for the next stage, the dance of the 5-axis machines and the world of micrometers. Now we enter the world of extreme precision. If casting was the birth, then machining is the education where the metal learns its final form. The cutting tools are often tipped with industrial diamonds, the only material hard enough to carve through the heat-resistant alloys we created in the foundry. The constant flow of coolant prevents the metal from warping under the heat of friction, maintaining the integrity of the design throughout the carving process. These machines move with the grace of a ballerina, but the strength of a titan, carving out geometries that were impossible to create 20 years ago. Behold the Blisks, an engineering marvel where the blades and the disc are machined from a single solid block of metal for maximum structural strength. If normal steel production is like making pasta, then this is like carving a cathedral on a grain of sand. The precision is simply breathtaking. These tiny holes drilled by lasers allow cool air to create a protective film over the blade, preventing it from melting in the engine's inferno. A human hair is 50 micrometers thick, but these cooling holes are even finer. They are the secret to why modern engines are so incredibly efficient. We measure in micrometers. A deviation of just 5 microns, 1/10 the thickness of a hair, is enough to send a part back to be recycled. In this realm, close enough does not exist. Every curve, every angle, and every surface must match the mathematical perfection of the original digital design. This digital verification ensures that the aerodynamics will be exactly as the engineers intended, providing the maximum lift and thrust for the aircraft's flight. It is a symphony of technology and art. Each blade is a sculpture of aerodynamic perfection, Born from the most advanced manufacturing techniques available today, the metal has been shaped, drilled, and polished. Now, these individual components must come together to form the powerful rotating heart of the jet engine. The math becomes physical reality. Every micrometer carved by the CNC machines translates into tons of thrust and fuel efficiency during the flight's cruise phase. From a raw block of alloy to a masterpiece of mechanical engineering, the precision phase is complete. Now, we prepare for the challenge of perfect balance. Think about the vibration of a dusty ceiling fan. Now imagine a multi-ton steel rotor spinning at 15,000 revolutions every single minute of operation. At these speeds, even a tiny speck of dust out of place would create a centrifugal force so powerful it could turn the engine into a bomb. Balance here is not just a goal, it is a religious commitment to absolute stability. We adjust the weight until the vibration is practically zero. The physics must be perfect. Each component is balanced individually, then the entire assembly is balanced again as a single unified rotating system of power. We use ceramic bearings because they are harder, smoother, and more heat-resistant than steel, allowing the shaft to spin with almost zero friction or wear. Every bolt is tightened to an exact specification. The click of the torque wrench is the sound of safety, ensuring that nothing will ever loosen. The core of the engine takes shape, layer by layer. Each stage of the compressor squeezes the air more tightly, preparing it for the combustion chamber. This is the nervous system of the machine. Thousands of sensors will monitor the engine's health in real time, providing data to the pilots and engineers. The tolerances are so tight that these massive sections fit together with less than a hair's width of clearance, ensuring a perfectly airtight seal for combustion. Look at this coin. Even as the engine behind it generates thousands of pounds of thrust, the vibration is so low that the coin doesn't fall. This is the culmination of thousands of hours of labor. The heart is built, the balance is perfect, and the machine is ready for its baptism. The smoothness of the rotation is checked by hand. Even a slight friction could indicate a problem that would be amplified at full operating speeds. Every joint is sealed with materials that can survive the fire. There is no room for leaks when you are containing an inferno within a metal shell. It moves like a sleeping giant. Soon, this silent piece of metal will wake up and roar with the power of 10,000 horses combined together. Each engine is a unique individual with its own story. Now, it must prove its worth in the most grueling tests ever devised by mankind's engineers. Before it can carry a single passenger, every engine must pass through the inferno. The test cell is a fortress of concrete and steel for safety. It is wired like a patient in an intensive care unit. Every vibration, every temperature change, and every pressure fluctuation is recorded and analyzed instantly. This is the moment of truth. The engineers watch the data streams, looking for any sign of weakness as the engine is pushed to its limits. In the bird ingestion test, we simulate the worst-case scenario. The engine must be able to shut down safely or keep running after a strike. We freeze the engine and blast it with ice to ensure that even in the middle of a winter storm, the fire inside never goes out. The startup sequence is a choreographed event. Fuel meets air, the spark ignites, and the sleeping giant wakes up with a roar that shakes the ground. At full throttle, the engine produces enough power to light a small city. The heat produced is intense enough to melt the very walls of the room. The air exiting the engine is moving faster than the speed of sound. This is the raw force that defies gravity and moves mountains of metal. There is no such thing as a grade of 9 out of 10. Here it is either a perfect 10 or it is a total failure. Thermal maps confirm that our cooling systems are working perfectly, keeping the metal surfaces just cool enough to maintain their structural integrity during the heat. Material science allows these blades to flex without breaking, absorbing the energy of the air and converting it into efficient, reliable thrust for the journey. Even in a deluge that would drown a normal car engine, the jet engine continues to burn, proving its reliability in the most extreme weather conditions. The test is over. The machine has survived the Hoanuk and has earned its right to fly among the clouds and carry our dreams aloft. Post-test inspections are just as critical as the test itself. We look for the smallest signs of wear that could indicate a future problem in flight. Certified and proven, this heart of steel is now ready to be joined with its wings and take its place in the grand tapestry of aviation. Every time you look up and see a white streak across the sky, remember the millions of hours of labor that made that moment possible. Today, it is a testament to the greatest minds and the most precise machines on the planet, pushing the boundaries of what is possible for our species. These are the silent heroes who work in micrometers so that we can travel in kilometers, connecting the world through the power of precision engineering. And the journey doesn't end here. We are already designing the next generation of engines using electricity and sustainable fuels to protect our precious blue planet. From hydrogen to hybrid electric, the future of flight is being written right now in the same labs where we mastered the art of the turbine. The jet engine does not just push an airplane, it pushes our entire civilization forward into an era of unimaginable speed and global connectivity for all. Thank you for joining us inside the heart of the sky. Human wisdom is the true engine that will always keep our dreams flying high.